Disconnecting the recovery trigger coil. Connecting the recovery drive trigger coil. Use the LED. Gain speed. These batteries aren't really connected to anything. So I can use the back EMF to either light this LED or to drive the yellow recovery drive. The recovery drive means it has its own circuit that recycles its own input, and that input is the back EMF of the other two pairs of coils. So here I'll make the back EMF drive the LED again. Disconnect the trigger coil for the recovery. Do that with one hand. So that's 10.8 volts input, 710 milliamps. This is a 100-watt LED that requires a 24-volt input. Let's reconnect that again. You can hear the motor speeding up. And we can disconnect the trigger coil for the other coils. So let's take one of the primary drive coils. So you hear the motor slowing down. Voltage went down. I'm going to try and reconnect it again. We're at 8 volts, 1.78 amps. 8 volts, 8.2 volts, 1.77 amps. So we have the same voltage and current with doubled output. And here's a scan of what's going on the back EMF. So we got 2 volts per division. The purple line is the voltage. So it looks like it's around 4 volts roughly of input. Now when I switch to the LED, it goes up to whatever is required for the LED, which is 24 volts. So let's make that 10 volts per division, and then turn off the recovery drive. Now we're at 10 volts per division, which is 24 volts. And reconnect. So, two of the drive coils run on a Bedini SSG kind of modified pulse motor circuit, or two of the pairs of drive coils, and the back EMF is fed into a circuit, like I said before, that recovers all that energy from the back EMF, and then recovers its own back EMF. But it's not free energy, it's not even close, but it is a really efficient use of energy. As far as power, this configuration is not that much. It's air core. But one thing that is kind of cool is that I turn it off. I set it up so that it uses a Hall sensor to start up. I have this little momentary on or momentary close switch that'll turn on the Hall switch, and then I can turn it off. And I have to have it turn off because as the motor uses more voltage, that Hall sensor starts to get the generated energy, and at a high enough voltage it'll just run out the Hall sensor and the LED. Alright, that's it for this one. Thanks for watching.